right? So what is meant by cathodic protection? First, you have to understand what is meant by cathodic protection. See, there are different types of corrosions, damage mechanism. There is one type of corrosion is called galvanic corrosion. So first, what do you mean by galvanic corrosion? For galvanic corrosion, we need four things. First one is a anode. Next one is a cathode. Third one is the electrolyte. And the fourth one is the electron flow. So electron flow through electrical connection. Right. Now, what is the definition of galvanic corrosion is when two different conductive materials are connected by a conductor. For example, conduct like electrolyte, that a conductor is called electrolyte. There will be electron flow between them. Okay. For example, I have a material, one material here and another material here. In between, there is a electrolyte. There will be electron flow from one to here. Electron flow, where electron flow happening is called as a anode, which is receiving electron is called as a cathode. So anode, there will be corrosion. Cathode, there will be a protection. Okay, this reaction is called as the oxidation. This reaction is called as a reduction. So we need two different conductive materials. From one side, one to another one, there will be electron flow. Okay, which one losing electron is called as this is losing electron, this is gaining electron. This is called as the oxidation. The reaction is called oxidation and it is called as anode. The losing electrons will cause corrosion, whereas the gaining electrons will not corrode. Okay, that is called as a cathode. That reaction is called as a reduction. This is called as a galvanic corrosion. Okay, this is the basics of galvanic corrosion. Now, if you take a storage bottom of your storage tank, this is my storage tank. So this is my storage tank. At here we have a soil, and this is my bottom. Suppose, say this is my tank bottom. Suppose I have some other material inside. There is a possibility of electron flow from the tank. Then what will happen? The tank will corrode very severely. To avoid that, what I want to do, I want to reverse the reaction. Reverse the reaction is I am going to install some known material which will be anode to the tank. So the electron flow should be, I want the electron flow like this, from the material to the tank. This arrangement is called as a cathodic protection. That's all. So to protect the tank, I am going to install some other material which is called as a anode, or we call it as a sacrificial anode, because it is official anode. Because this will going to lose electrons, whereas tank is going to gain electrons. Is it clear? So now tank we changed to cathode. We have already anode. The soil will be the electrolyte. Electrolyte will be the soil, because soil have moisture contents. It will be a natural electrolyte. So to make a electron flow, just I will put a wire connection here. There will be electrical connection. I will make a wire connection. Then there will be a cathodic protection. This is called as a cathodic protection. You understand basic principle of cathodic protection? Just a galvanic corrosion, we are reversing the galvanic corrosion so that the tank bottom can be protected and the anode will corrode fast. Okay. This is called sacrificial anode. This arrangement is only suitable for small tanks, because there is no external current. We are not passing any current. It is a natural electron flow. Just we are putting some circuit closing wire. That's all. It is a natural. There is no external source. This arrangement is possible. This we effectively work for a smaller tanks as well as low resistivity soil. Suppose the soil resistivity is more, the electron flow will not happen. So for a larger tanks, what I want a forced current. I want the external power source so that current can be forced. That type of arrangement is called impressed current cathodic protection system. So we have two types of cathodic protection system. One is the sacrificial anode cathodic protection system. Here there is no external power source, no external transformer or generator, nothing, rectifier. But this is suitable for a small storage tank and less resistivity soil. But what is the advantage of this one is no external power supply required. Initial cost is less, maintenance cost is less. So everything is very cheap arrangement, very cheap this one. But the disadvantage is it is not suitable for the large tanks and high resistivity soils. The next arrangement what we will have a rectifier. What is meant by rectifier? Which will change the AC current to DC. Okay, so the rectifier will supply the electrons. That is, we will supply the electrons to protect the tank. So rectifier should supply the electrons to the anode, from anode to the tank, from the circuit will be close to the tank to the rectifier. This is the arrangement that is called impressed current. Okay, impressed current cathodic protection system. What is the advantage of impressed current cathodic protection system is it is suitable for large tanks and high resistivity soil. What is the disadvantage is initial investment is high, just everything will be opposite. Maintenance cost is high. There is one thing called stray current problem will be there. Sometimes, suppose we have some other metal, current will go in that direction instead of going to the tank. Okay, these are some of this is the basic of the cathodic protection. So you understand this? What is meant by cathodic protection? Now I will go through the first video. Then we'll go through the PowerPoint. So corrosion is an electrochemical process that occurs within a corrosion cells. So we have four: anode, cathode, electrolyte, and metallic path. This is the current flow. The current theory is opposite electron flow. Don't confuse that one. Corrosion is electrochemical. Metal loss corrosion occurs the anode oxidation reaction, and no metal or cathode is called a reduction reaction. Potential means voltage.
Imagine this scenario. You buy a little known cryptocurrency at $2.82 from a major exchange. The coin surges to $26.50. And then you a nine-fold gain. Yes. You buy the same cryptocurrency. But this time, you buy it using a perfectly legitimate.
Okay. Right. So this is one of the anode system. Now the latest technology, these are. So these are the anodes actually, ring anodes. They are keeping before the tank bottom plate. They will lay the anodes. Eh? Yes, they will lay the anode. Then after that, only the bottom plate will be erected. Yes. Yeah. Now they are coming wire type anode only. Hmm. This is called ring anode. We have more videos. I have impressed current one video. So the metal being protected is called, this is related to piping, but the same only, it is same. So these are the anodes. So this is the rectifier. So rectifier will be connected here. From this, there will be a flow, electron flow here, from electron to the rectifier. Now, generally for galvanic, we are using magnesium or zinc. Okay, magnesium will be used as a cathode, anode, sorry. And here we are using sometimes platinum also.
Our question one.
Oh. Okay. Now we will go through the PowerPoint, then we will go through the class. So this is how the reaction is happening. Right. So you can see this is the current flow. This is called as anode, where the corrosion takes place, and the cathode will be, there will be electron flow here, it will be protected. Now there are, so this is whenever there is a, see, that's why when you make a pad, it should be clean and uniform pad. If a pad you have a clay or sinter means the coal blocks, or even small stone, where they are contacting the tank bottom, that area will cause a pitting corrosion. That is called, because there is a gap, we call it as a crevice corrosion. Gap corrosion is called as a crevice corrosion. It will be pitting type, and in future it may make a hole on the tank bottom. Then this is called stray current. What is meant by stray current? Actually, I have a rectifier and I want to protect this piping. This cathodic protection is installed to protect the piping actually. But suppose in between there is a storage tank is located, the instead of current going from anode to pipe, it will go to the tank. So tank one area will be protected, other area it will pass the current to the piping. This area will corrode. Even a tank bottom, half of the tank bottom will be protected, remaining half will be corroded fast. Okay, this is called stray current. It means current flowing in a unintended direction, unwanted direction. If it is flowing, then we call it as a stray current. See, please remember, stray current is a problem only when you are using the impressed current system, because we have external current. The galvanic, what you call the sacrificial anode, there will be no stray current problem. Again, understand the steps. There should not be any tank here. So this was used to protect the piping. But suppose a tank is installed in between by mistake, then one part of the tank will be protected, other part of the tank will be unprotected. It will corrode more. Then this is what is meant by galvanic corrosion. See, galvanic corrosion I told for galvanic corrosion, we needed two different conductive material. A classic example is, suppose you make a weld or bolted connection with the carbon steel with the stainless steel, the carbon steel will corrode more to compensate for the stainless steel. That is the basics of the galvanic corrosion. Okay. You can see here, this is the tank bottom. Here we have here some another non-copper or stainless steel. Then there will be more corrosion here. So this is how the soil, I told you yesterday, you remember 571 class? Soil porosity is difficult to measure directly. So we are measuring the soil resistivity. A higher the resistivity, lower the porosity. The unit of resistivity is ohm centimeter. Suppose a resistivity less than 500, very low resistivity, it is very corrosive. If it is resistivity 500 to 1000, it is corrosive. 1000 to 2000, moderately corrosive. 2000, 10,000, mildly corrosive. If the resistivity is more than 10,000, it is less corrosive. So more the resistivity, less corrosivity. So this is the different type of pads. This is called concrete pad, continuous concrete pad we have. This is oiled sand. Now, if you are using a concrete pad, generally cathodic protection is not required, because cathodic protection, what is the purpose? Soil corrosion. If you are using concrete pad, so cathodic protection, still you want to protect it because you think there will be water may be going inside. You put anode on the around the tank, on the perimeter of the tank. And this is oiled sand. Sometimes, not in all countries, they are using Chinese oiled sand. They have sand with oil coming, oiled sand. But if you are going to, if you are planning to go for cathodic protection, oiled sand is should not be used because oil sand will have high resistivity. For effective cathodic protection, the sand or soil should conduct the current. Then only there will be effective. It is a high resistive soil, so cathodic protection will not work properly if you are using oil. Another one is the asphalt. Asphalt means our same, we are using coal tar, we are using the roads, everything. But asphalt also should be discouraged if you are planning for the cathodic protection. The reason is, if you asphalt in time, it will crack. What will happen in the crack? There maybe it will absorb water through the cracks. Even the cathodic protection is there, still it may not work effectively. It may still make a corrosion because of the water contact. Then this is a partial galvanic series. If you see here, this is our normally using steel. Now, this is a potential voltage. If you see the steel, it is not a complete steel. Actually, more noble. Which one is the more noble material? Noble means which will not corrode at any circumstances is platinum. Platinum is the highest noble material. Next one is the gold. Next one is silver, like that. If we take steel, above steel, they are more corrosive. What are the above steel we have in the list? Aluminium, aluminum alloys, zinc, magnesium. So aluminum, zinc, magnesium, these three only anodic to the steel. That means they will corrode more than steel. If you want give the sacrificial anode cathodic protection, you have to either use any three of this. Generally, aluminum is not used. The reason is aluminum very close conductivity, it will not have much effect. So preferred one is either zinc or magnesium. Zinc or magnesium. You need the voltage. If you see this, mild steel, this one, carbon, if you see here plus the 0.3, they will have minus, magnesium will be 1.75. And this is how we are using the galvanic anode. There will be an anode, there will be a wire connection. Okay, the electron flow from the anode to the tank bottom. So anode will corrode and the tank will be protected. I told you it is only used for a smaller tank. So this is how the rectifier arrangements work. So rectifier, there will be a electron flow from the rectifier to the anode, from anode to the tank, and there will be a return circuit. This all the sketches are in your book is there. It is from book only. Now, how you are installing the anode? See, this is the one called below the soil. We can use the like that horizontal anode. Impervious external line beneath the above ground stage. You can install anode horizontal also. It can be wire type also. This is a tank jacking. So anodes installed. Suppose you are going to install a new bottom. You remember new bottom, how we will complete that, clean the tank and fill with the soil, then we will install a new bottom. So anode can be installed between the old and new bottom like this. Okay. So that, but generally when you are using soil, the old bottom should be removed. Old bottom shields existing. Otherwise, there may be possibility of reverse current flow also. Now, there is one thing called a deep anode. Deep anode means not for this sacrificial, this one. Impressed current, they will install anode in the very deep, more than 50 feet. That is called a deep anode. So when you install the anode, they will, it is a carbon. Carbon means what is called carbon inside carbon powder, like our battery cells. Carbon bag, they will install the anode for uniform conductivity and it will be buried here like this. There will be this before it is there. This is how to check whether the cathodic protection is working properly. Okay, so periodically we will check using the ammeter, temporary anode bed. This is a copper sulfate reference electrode we will install and check how much current is flowing. This is again how to check it from the tank. They will give the electrical connection to the tank and they will use a electrode, reference electrode. See, when the current flow is properly is there, then cathodic protection is effectively working. For effective cathodic protection, we need a current flow. We will give voltage. That should be what is the input and what should be the output. There is a values are there. If the output is not coming, means there is no electron flow. That means cathodic protection is not working effectively. These are the reference electrode generally we are using. Normal use is copper sulfate, but you can use the calomel and silver chloride or zinc also. Now, this is how the deep anode is installed. This is the carbonous back and a special backfill we are using. Commonly installed deep anode. So deep anode will be installed in the series of electrodes. Deep anode will be like this. So these are the horizontal, this one. Okay, these are the key points. Come in front. Okay, what is this one? This is the tank bottom extension. In cathodic protection language, it is called as CHIM or CHIN. CHIM or CHIN means the extension. Well, how much should be the extension? You remember, as per 650, from the shell, it will be 2 inch. From the weld toe, half an inch, whichever is greater. As per 653, from the weld toe, it should be 3/8 inch, 3/8 inch. But this is only called CHIM or CHIN. And this is the deep anode electrode, how they install using the pipe. So the arrangement will be like this. Okay. Now we will go to the code book. So please take the code book. 651. If you see the body of knowledge, because all chapters are not part of our exam. If you see the body of knowledge, no need, I will show you. Okay. In our body of knowledge, you can see here 651 cathodic protection of above ground storage tank, only sections 1, 2, 3, 4, 5, 6, 8, and 11 will be covered on the examination, which is in page number 12. Okay. So that means which are the chapters are not part of our exam? 7 is not part of the exam. 9, 10 is not part of the exam. So we will exclude during the class. We will not cover chapter 7. We will not cover chapter 9 and chapter 10 also. So 7, 9, 10, these are not part of our exam. Is it okay? Right. So generally 651, there will be around 6 questions in the exam. Again, I'm repeating, very easy to score. Just to understand this, 651 around 6 questions, 652 around 6 questions. So you should score it easily actually. So please, page number 3, highlight this one. What is meant by above ground storage tank? An on-grade stationary uniformly supported container, usually cylindrical, metallic roof, where more than 90% of the tank is above the surface grade. Above ground means as per 651 and 652, at least 90% should be above the ground. That is called above ground storage tank. Even 10% below the ground, still it is considered the above ground. Anode, highlight this one. The electrode or electrochemical cell at which oxidation occurs, where oxidation occurs is called anode. Cathode, anode bed. What is anode bed? Consists of one or more anodes installed below the earth surface for the purpose of supplying the cathodic protection. Then what is cathode? The electrode or electrochemical where reduction reaction occurs. So reduction means the receiving of electron. Oxidation means the releasing of electrons. CHIM or CHIN, the portion of the tank bottom steel floor that extends horizontally past to the outside vertical surface of the shell. Okay, also referred as a bottom extension. So bottom extension, CHIN or CHIM, all are same. The next page, Koch breeze. This is closed book question. A commercial carbonaceous backfill material, which is used when you are using the deep anode. Then concentration cell corrosion, again a open book question. A form of localized corrosion initiated by difference between metal ion and oxygen concentration due to crevice. Crevice na gaps. Okay, that is called concentration cell deposits and difference in oxygen concentration in the tank bottom. See, when there is a difference in oxygen concentration, the area which have low oxygen will corrode more than the area with the high oxygen. Because there will be more inflow of oxygen, so it will corrode more. That's why when you should have, for example, I just for understand, suppose I have here, this is my structure, and I have a pipe like this. A pipe like this. This area, you can see here, even the pipe is touching here, there will be a gap here. This is called concentration cell corrosion. So wherever there is a gap, this problem will come. For example, if you have two plates lap, but which is not welded, one side only you are welding. If there is a gap here, this problem will come. Wherever there is a gap, there will, yeah, there is, we have to seal it. Otherwise, what will happen? There will be a concentration cell corrosion because of difference in oxygen. So highlight this one, localized initiated by difference oxygen content due to crevice deposit or difference in oxygen content on the tank part. Now, deep anode bed. See, if anode depth is more than 50 feet, deep anode, less than 20 feet, it is called shallow anode. These are closed book question. Deep anode means one or more anodes installed vertically at a nominal depth of 50 feet or more below the earth surface in a single drilled hole for the purpose of cathodic protection. Generally, impressed current, we are using deep anode. So it will be a series of anodes installed more than 50 feet. 50 feet of deep, we will call it as a deep anode. Then differential aeration cell, that is also open book. The electrochemical cell on electromaterial which use difference in oxygen content, one part of the tank as compound. So that is called a differential aeration cell, and the concentration corrosion cells, both are same. Only thing is, the form of localized corrosion is called concentration corrosion. Differential aeration is where the gap is called differential aeration. Both are same only. Then potential. What is meant by potential? Voltage. Okay. The potential of an electrode as measured against a standard reference electrode. How much volt it is coming through the soil. The electrode potential does not include any voltage measurement error due to passage of the current through the resistance or metallic or electrolytic path. Then electrolyte, a chemical substance containing ions that migrate in an electric field. For the purpose, the electrolyte refers to soil or water adjacent to and in contact with the bottom. That is called electrolyte. Then holiday. So you know holiday, it is a discontinuity in the lining or coating. We call it as a holiday. A discontinuity in the protective coating that exposes the underlying substrate to the environment. That is called holiday. The test is called a holiday test. See, what holiday test we will use here? High voltage, low current. Brush type electrode we will use. It is actually not for the soil corrosion. Lining only use. Impressed current, an electric current supplied by a device employing a power source that is external to the electrode system. An example is direct current cathodic protection rectifier. Then IR drop. What is meant by IR drop? Means Ohm's law. V is equal to IR. What is the voltage drop? We call it as IR drop. The voltage generated across a resistance by an electric current according to Ohm's law, E is equal to IR for the purpose. The most significant is the portion of the structure to soil potential. Oxidation, the loss of electron by a constituents of a chemical reaction. Loss of electron, we call it as oxidation. I told receiving electron, we call it as a reduction. Rectifier, a device converting alternating current to direct current, usually include a step-down AC transformer, a silicon or selenium rectifier elements, meter, and other accessories. Reduction, the gain of electron by a constituents of a chemical reaction. Then reference electrode, the electrode whose open circuit voltage is constant under similar conditions. So reference normally used electrode is copper sulfate, reference electrode. So we have to for measure how much voltage is coming through the soil. But there are other calomel, aluminum, these are also can be used. Then shallow anode bed, very important, close book question. A group of cathodic protection installed individually spaced uniformly buried less than 20 feet. See, for small tanks, for this one, sacrificial anode, we will use a shallow anode. When you are using for impressed current, we can go for a deep anode. Deep anode means 50 feet and more. Shallow anode means less than 20 feet. That is called shallow anode. These are closed book questions. Shunt, a conductor of a known electrical resistance through which a current flow may be determined by measurement of the voltage across a conductor in accordance with Ohm's law. Stray current, very important. Current flowing through the path other than intended circuit. There is another name of stray current, is called the interference current. Just write the nearby, stray current or interference current. Interference current, stray current, both are same. Interference, INTER, FERENC, both are same. Then we will go to the next page. We will skip many things actually. Page number 8. There are 4 components required for a corrosion shell. Highlight this line: anode, cathode, metallic path connecting the electrode and the cathode, and an electrolyte. That line highlight. So this is picture. Then 4.12. There are many forms of corrosion. Highlight this next line. The most common type relative tank bottoms are general and localized pitting corrosion. In general corrosion, thousands of microscopic corrosion cells occur in an area of the metal surface, resulting in relatively uniform metal loss. In localized pitting corrosion, the individual corrosion cells are larger and distinct anode. So pitting means one area there will be a deep corrosion. Uniform means every area it will be uniform. Highlight this one. Then highlight 413, next paragraph, second line. Difference in electrochemical potential between adjacent areas can result from uneven distribution of alloying elements. Corrosion can also occur in difference between the welded metal, heat effect zone, and the parent metal. That line is important. So welded parent and this also, there is a difference in the corrosion. The next page, 4.1.4, third line. Areas with lower oxygen concentration become anodic. It will corrode more when the oxygen is less. And areas with higher oxygen concentration become cathodic. This phenomenon causes corrosion of steel tank bottoms on homogeneous sandbed, or when contaminated with the clay or debris. Suppose if you have some debris, that area there will be a crevice. Suppose you have a stone. That's why the pad should be a same size. Okay, sand size will be very fine sand you have used. So this is the corrosion occur where the rock or clay makes a contact in the steel. No, there is no question. Just I will mark it. We will check. Now, stray current, very, very important. Stray currents, also known as interference currents, travel through the soil electrolyte and onto structure for which they are not intended. If the current flow is other than the intended direction, it is going another direction from what you are actually planned, then it is called a stray current. Usually, the affected structure collect the interference current from the electrolyte. The source of this current is not electrical connected to the affected structure. So, what is meant by stray? You remember, we have street dogs in every local. They are called stray dogs. Stray dogs means without any control. There is no owner for them. Everybody is owner in the street. Okay. Then this is important. The most common and potentially most damaging stray currents are direct current. That line is important. The direct currents are most damaging. Next line is open book question. These currents are generated from grounded DC electric power system, including electric railroads. Suppose any railroads are there, electric railroads, there will be a stray current problem. Subways, welding machine, impressed current cathodic protection system, and thermoelectric generators. That is open book question. From where the stray currents can. The next page, galvanic corrosion. Highlight this one, 4.2.2. First 3 line. Galvanic corrosion occurs when two metals with a different composition are connected in an electrolyte, usually soil. Current will flow from the more active anode and the less active metal cathode with the oxalate attack on the anodic metal. That is called galvanic corrosion. So highlight the last one. The most significant factors are the relative surface areas of the cathode anode and the relative potential difference between the two materials as determined by the position in the series electron. On the table, what is their position? See, in the table, anything which is far away will have more corrosion. Please remember, if anode is corroding more, cathode will be protected more. Anode corrosion more, no, it will. Anode is not corroding means cathode also not protected. It should corrode more. So for that, the distance should be more in the table, the galvanic series table. And the temperature. Temperature and the corrosion rate are related. When the temperature increase, corrosion rate also will increase. Corrosion tends to be more severe when the anodic area is small with respect to the cathodic surface area and the two metals are far apart in the galvanic series. Very important. See, what is the meaning of, what is the size of anode you should use? Suppose if you use a very big anode, okay, anode very small, it will have, what is this one? Corrosion rate more severe when the anodic area is small. Area should be small area. That's why we are using small anodes. Tank bottom area is a big, so it will corrode more severe. Then internal corrosion. Now, can we give catalytic protection on the inside of the storage tank? Yes, it is possible. Okay. Experience has revealed that corrosion may occur in the inside surface of the tank bottom. The extent nature of the corrosion depends on the many factors associated with the composition of the fluid in contact with the steel bottom. The most influence in the severity, this open book, conductivity, suspended solids, pH level, dissolved gases as CO2, H2SO2, sulfate reducing, and the temperature. This all influence the inside corrosion. Then determination need for catalytic protection. Now, page number 12, 5.1.1. See, catalytic protection can be even in the design stage itself, tank design, they can go for a catalytic protection. Okay, then it will be pre-planned, so we can properly implement the anodes. Sometimes after some years of service, if they think the bottom is severely corroding, they can go for catalytic protection also. So, and corrosion control by catalytic protection for new above ground storage tanks should be included in the initial design unless a detailed study indicates it is not needed. If catalytic protection is applied, it will maintain during the service life of the tank. So if you go for catalytic protection from the starting, it should be maintained during entire service life of the tank. That is important. Close book question. Now, existing above ground storage tanks, and evaluation should be conducted in accordance with the 653 to determine the need for catalytic protection. When the studies indicate corrosion will affect the safe or economic operation of the tank, adequate corrosion control measures should be installed. Then internal catalytic protection. Pure hydrocarbon fluids are usually not corrosive and do not require corrosion control for internal surfaces. However, based upon experience, internal corrosion will occur in above ground storage tanks that have internal surfaces exposed to water, sediment, and other contaminants. Generally, coatings are used to reduce and eliminate corrosion on the internal surfaces. The next line important. For tanks in petroleum service, internal catalytic protection in conjunction with the coatings can be used, and it can be effective in protecting against corrosion at all days in the coating. Now, limitation of external catalytic protection. See, what are the limitation? I told if you use a concrete pad, the soil should be the conductive material. Catalytic protection is an effective means of corrosion control only if it is possible to pass the electrical current between anode and the cathode. So there should be a current flow, then only it will work. Many factors can either reduce or eliminate the flow of electrical current and therefore may limit the effectiveness of the catalytic protection. So examples, tank pads such as concrete, because concrete will not conduct a current. B, a non-conductive, suppose you have a liner bottom, the liner may restrict the flow of the current. Bottom and the anodes, unless anodes are installed between the liner and the tank bottom. Then C, high resistivity soil or coarse or larger characteristics. Suppose soil resistivity is more, it will not work effectively. old above ground storage tank is there, then it may shield the current. Left in place where new bottom is installed. These are the reasons which will affect the cathode potential. Then these are not important. Please go to the page number 14. Tank pad soil conditions. 5311 second paragraph, highlight this line. The use of fine particles. So we have to use a fine sand particles to provide denser pad that help to reduce the influx and outflow of oxygen from the perimeter of the tank as it is emptied and filled. If large particle size are used, differential aeration corrosion may result at points where the large particles debris contact the tank. So when they are contacting, see, we should use sand, fine sand. If it is using coarse grains, coarse crystals, then there will be a contact point corrosion. இதுக்கெல்லாம் சலிக்கிறாங்கல்ல, மண்ணு சலிக்கிறாங்கல்ல, அந்த மாதிரி யூஸ் பண்ணும். Yeah. Now, this is the resistivity table. This is important, open book question. Less than 500, very corrosive. Greater than 10,000, less corrosive. This is open book based on the resistivity and the corrosivity of soil. Open book question. Then sand pad, 5.3.2. Clean sand is the most common material used as a pad beneath above ground storage tank. The use of clean sand alone normally does not eliminate the need for cathodic protection, since corrosion may occur due to the intrusion of water from rain, snow, or a shallow water table, condensation, or other corrosion. So that is about the sand pad. Sand pad material. How we are preparing the sand pad? The sand should be clean, screened, and debris free. No wood, sticks, vegetation, paper, rocks, clay, all these things. And for compaction, they will add some cement. 33:1. 33% sand, 1% cement, they will add it, Portland cement, so that it will compact. The pad will be compact. This is next line, highlight this one. E, next page. Portland cement at approximately 33:1 sand to cement ratio, or lime at an approximately 95:5 is sometimes added to supply source to elevate pH and facilitate good compaction. Yeah, that is, we are using lime. Then measuring G, highlight, measuring the pH indicates the hydrogen ion content of the soil. Corrosion of steel is fairly independent of pH when it is a range of 5 to 8. Then sand pad construction 5322. This is important, close book question. Sand is often installed by loose lift, maximum 6 to 8 inch thickness. What should be the sand pad thickness? Minimum 6 to 8 inch thickness you have to use when you are making the sand pad. Then please go to the next one, concrete pad. 5331, this is a open book question. A properly designed concrete tank pad constructed on stable, properly prepared subsoil may be effective in eliminating intrusion of groundwater, soil side corrosion, and the need for cathodic protection. If the concrete pad is there, there is no need for cathodic protection actually, because through concrete, only soil will corrode. Then suppose the soil is not stable, then the concrete can break. Then there will be a water intrusion. Unstable soil may induce cracks in the slab through which water and contaminants can permeate to the steel tank bottom and provide a corrosive environment. Then 5332, highlight this one. Yes, please.
Sir, in the morning when you played one of the video, it shows it was having a concrete pad, and on top of it, it was having a wire type
Yeah.
anode ring.
Yes, but below concrete pad, see, if you are using concrete pad, actually cathodic protection is not required.
Okay.
If you want to install cathodic protection, you have to install above the concrete pad. Just I shown to the video. If you put below the concrete pad, it will not work.
Okay, okay, sir.
Although corrosion from your soil may be prevented by a concrete pad, there may be still a collection of moisture between the tank bottom and the pad due to condensation, blowing rain on snow, flooding due to inadequate on the tank down to the tank. So that's why they are using, if you are, what you asked the question, the morning the video, concrete pad, above they are installing a anode. It can be installed. Okay. Then limestone and clamshell. Okay. In certain locations, the tank pad could consist of a layer of crushed limestone or clamshell. Such tank pads without the use of cathodic protection have produced mixed results. The tank pad should be fine and uniform. since the differential aeration will cause pitting at the contact edges. So if there is a large particle you are using, there is always a pitting corrosion. Then oiled sand. Highlight this the second line. If a cathodic protection is applied, the higher resistive of the oil sand may prevent it from being effective. For new tank construction, use of oiled sand is discouraged. So use of oiled sand is discouraged. Use of asphalt pad also discouraged. Resistivity, because of the resistivity, there will be no current flow. Yeah, of course. See what they are selling. If you are because they are high resistivity, the corrosivity will be less. For that, if you are using oil, then don't go for the cathodic protection, because cathodic protection will not work effectively. Then continuous asphalt pad. Highlight this one, third line. Asphalt decreases with the time and provide a path for water. Underline this also. Third line. And a dissolved contaminants to come into contact with the steel tank bottom, allowing corrosion to occur. Cathodic protection, if applied, may or may not aid in stopping corrosion when the asphalt becomes deteriorated. The last line, for new tank bottom construction, use of asphalt pad is discouraged. That is important. This was recently asked open book question. Asphalt நம்ம இது தார் போட்டோம்ல, chips and tar, whole tar. Then other factors affecting the cathodic protection. Highlight this one. Yes, this one. Yeah. Above ground storage tank temperature can influence the corrosion on tank bottoms. Accelerated corrosion can occur on the external surface of the tank of heated tanks due to elevated temperature or the area. Suppose you are using heating coil in the tank bottom, so the bottom corrosion rate will increase because temperature and the corrosion rates are directly related. Every 10 degrees centigrade increase in temperature, corrosion rate will be double. That is the next one in open book question. The corrosion rate of steel may double with every 10 degrees centigrade or 18 degrees Fahrenheit increase above 25 degrees centigrade. That is open book question. Now, galvanic system, page 6.2.1, highlight the first two lines. Galvanic system uses a metal more active than the structure to be protected to supply the current required to mitigate the corrosion. The more active metal is called anode, commonly referred as a galvanic anode. Then the fifth line is important. Most metal used in galvanic anodes in soil are magnesium or zinc. So we are using magnesium and zinc in either cast or ribbon form. The anodes are usually distributed around the perimeter of the tank or preferably buried beneath the tank bottom. Galvanic systems are normally applied only to small diameter tanks less than 20 feet or tanks with the externally coated bottom. So they are suitable for the small diameters. That is closed book question. Now this is the table partial galvanic series. You can see what is the voltage of noble here. Carbon is plus 0.3. This is open book question. They asked in one exam. Mild steel minus 0.5 to 0.8. Pure aluminum, magnesium will have minus 1.7. Minus not negative potential. Here will be plus. The sacrificial galvanic both are same. Now, what is the advantage? Please go to the page number 21. Advantage of galvanic system. There are several advantages. No external power supply is required. Installation is relatively easy. Capital investment is low for small diameter. Maintenance costs are minimal. Then this was asked in the closed book. Interference problem are rare. So because there is no high current, it is only there is no external current. Less frequent monitoring is required. So this is closed book. What is the disadvantage? Driving potential is limited. Current, the voltage generated will be very small. Current output is low, limited to low resistivity soil, not practical large bare sections. Now we'll go to the impressed current. The second method of applying cathodic protection to an above ground storage tank bottom used to impress current from an external source. Impressed current system uses different direct current usually provided by the rectifier. So why we are using rectifier? We are converting AC to DC. We want the current flow only in one direction. AC means it will be alternating. Okay. Now, what are the advantages? Just the opposite. Availability of large potential, driving potential, high current output, capability of variable, applicable to almost any soil. That is closed book question. Last one. Any soil resistivity, we can use it. Soil resistivity is not a problem. Then you can see disadvantage. Highlight the A. Possible interference problems, stay currents on foreign structures. C. Higher maintenance and operation costs. E. Safety aspects of rectifier location. F. Safety aspect of negative lead connection. This was asked in the open book question. Now, what you are using in the rectifier? See, either silicon or selenium is used. Silicon is the preferred one. Okay. Silicon rectifier generally more efficient. These are open book question. However, they are more susceptible to damage from power surges. Therefore, protective wire should be considered for these units to prevent lightning damage. Because of a decreased life at a higher temperature, selenium rectifiers are not recommended if ambient temperature is more than 55 degrees centigrade. So we have two types of rectifiers. Silicon. The silicon, the problem is power surge. There is a power fluctuation will be there. But selenium, when the atmospheric temperature increases, it will fail. So selenium is not preferred. Then anode. See, galvanic anode, what are the galvanic anode? Aluminum, zinc or magnesium. Here we can use a scrap steel or high cast iron or even titanium. Impressed current anodes used soil are made of materials such as graphite, scrap steel, high silicon cast iron or metals of oxides of titanium. Anodes are usually buried in a coke breeze backfill to extend their life and reduce circuit resistance. They may be located in remote anode but distributed around the tank, installed underneath or installed in deep anodes. This is open book question. So 7 is not part of our exam. So just to skip 7. So please go to the 8 criteria for cathodic protection, page number 33. So we have given you full book actually. Okay, 7 is not part of our exam. 8.2.1, that is open book question. There are several criteria used to determine if adequate cathodic protection has been achieved on above ground storage. For a more detailed, refer latest edition of NACE RP 193. That is open book question. Then how we will check whether it is working effectively? We will give the voltage using the reference electrode, like I told. How much it is returning, they will check. You can see the many YouTube videos are there, how they are checking the cathodic protection efficiency, effectiveness. A negative potential of at least 850 millivolt with the cathodic protection current applied. This potential shall be measured with respect to a saturated copper and copper sulfate reference electrode contacting the electrolyte. Voltage drops other than those across the tank to bottom electrolyte boundary shall be considered. So near the tank, using the electrode, they will pass the current. How much they will give? 850 millivolt. Then how much it is coming to the tank, they will check. Okay, by this one. Minimum, if it is 100 millivolt is returning, 850 millivolt we will give. Return should be at least 100 millivolt, then it is working. Then this is the one. A negative polarization potential 850 millivolt relative to one CSE, one common method polarization using the instant of technique. Highlight this one, that is open book. This criteria may be excessive and not practical for fair steel. Then this is important. A minimum 100 millivolt of cathodic polarization measured between the tank bottom and the metallic surface and a stable reference contacting the electrode. The formation or decay of this polarization can be measured, satisfy this criteria. So there should be a minimum 100 millivolt polarization.
Saying that we are giving 850 volts through rectifier to the cathode through anode.
No. That's not through the rectifier. We are giving around the tank by using a copper sulfate reference electrode. Okay. And the tank, there should be only 100 millivolt difference. If it is there, then it is acceptable.
100 milli difference, which means that 750 should be there.
Yeah, 750 it should show.
Okay. So we are measuring on the tank side from the while we are giving the electric current from the
soil due to the soil. Yeah.
Yep.
We will measure the soil to tank potential difference. That means it is working effectively.
Okay, sir. Thank you.
Measurement techniques. The standard method of determining the effectiveness of cathodic protection on a tank bottom is the tank to soil potential measurement. That is what I said. These measurements are performed using high impedance voltmeter greater than 10 ohms. That is open book question. And a stable reproduce a referential electrode contacting the electrolyte. So you can see the sketch here. This is the reference electrode. We will use it to the voltmeter and we will measure, connect to the another relay to the tank, and we will measure what is the difference. So here, how much it will put the input 850, there will be 100 millivolt difference can be there. So it should measure at least 750. That is the meaning of this. Okay. Yes, yeah, 750 we should say millivolt. Millivolt means 0.75 volt. Millivolt means 1 by thousands of the volt. எது இது வெல்ட் அடிக்கல, கிளாப் இந்த மாதிரி புல்டா கிளிப் மாதிரி டச் பண்ணுவாங்க, அவ்வளவுதான். ஆமா ஆமா, நம்ம இந்த இதுக்கெல்லாம் வெல்டிங்கெல்லாம் கொடுக்குறோம்ல, எர்த்து கொடுக்குற மாதிரி கொடுக்குறோம், வெல்ட் அடிக்கிறதுக்கு காமிச்சிருக்காங்க. Sometimes what will happen, this reference electrode can be permanently installed around the tank. Just clip பண்ணி மட்டும் பார்த்துட்டே வரணும். ஒவ்வொரு தடவை நீங்க இந்த ரெஃபரன்ஸ் எலக்ட்ரோட் இருக்குல்ல, அட்லீஸ்ட் 4 location they will permanently installed. ஸோ நீங்க ஜஸ்ட் அந்த கிளிப் வச்சு மெஷர்மெண்ட் எடுத்தா, ஆமா அது வேற, அது டு மெஷர் this actual material corrosion coupon is different. Periodically remove, and check how much it is corroded. Then 8.3 to highlight, the actual structural to soil potential under the tank should be determined by using a permanently installed reference electrode or by temporarily inserting a waterproof portable reference electrode under the tank through the non-porous non-metal. So either you can use permanently installed electrode or you can temporarily install it. Then 8.3.3 second, conservation of the IR drop in the soil is necessary for measurement made at the tank perimeter, even if the reference electrode is placed immediately adjacent to the tank. This is especially true with distributed ions are close to the tank. So IR drop, what is the actual IR drop also you have to measure. Actually, this is an electrical subject. Okay, but it is because cathodic protection is important. That's why they are included in the 653. So other reference electrodes may be substituted for the saturated copper sulfate electrodes. 3 commonly used electrodes are this one. See, what is the 850 volt? We will minus 8.85 means 850 volt. That is for copper. If you are KCl calomal, we will use 780. That is equivalent to 850 voltage equivalent. Silver we will use 800. Zinc we will use 250 plus side. This also can be used. These are considered equivalent to the 850 volt of the copper sulfate. If you are using other electrode, what should be the voltage you have to use?
There is 100
yeah, 100 millivolt the maximum difference allowed. Okay, now chapter 9 is not part of our exam. Chapter 10 is not exam, so we'll go to the 11th page number 43. Operation and maintenance of cathodic protection system, 11.1.2, page number 43. 11.1.2, highlight the second paragraph. Tank bottom to electrolyte potential readings may indicate adequate cathodic protection for the portion of the tank in contact with the soil, but when the tank is full and all the tank bottom is in contact with the soil, protection may be insufficient. Therefore, potential survey should be conducted with an adequate level in the tank bottom to maximize the contact. So when you are using this reading, the tank should be in the filled condition. You should not take the reading on the empty condition. Empty condition, what is problem? Some tank bottom may be not in touch with the soil. It is good practice to mark label location on above ground storage tanks where the reference electrode is placed to ensure consistency from survey to survey. Everywhere the same location we have to use a reference electrode. That will improve the accuracy. So if you change the location, there may be difference. The reference electrode வைக்கிறாங்களா. If cathodic protection devices are shut off while working on above ground storage tank, the system should be re-energized as soon as possible to avoid corrosion damage. Suppose you are making switch off because you are going to work inside the tank for safety aspect. Then once the inspection is completed, you are immediately start it. The next page, cathodic protection survey is very, very important. Prior to energizing a new cathodic protection system, measurement of the native soil structure to soil potential should be made. Immediately after any cathodic protection system is energized or repaired, a survey should be conducted to determine it operates properly. That is closed book question. Then this line, polarization to steady state may several months after the system is energized. The survey should include one or more of the following type of measurement. So what are the measurement you have to take? Polarized structure to soil, anode current. So these are the open book. This list is the open book. Highlight the open book. All the open book means anything can be asked. Now, when we have to conduct a cathodic protection survey, there are two regularly asked closed book questions. Cathodic protection survey, every year we have to conduct it. So cathodic protection survey using the reference electrode Zeeking reading, and every 2 months we have to check whether the rectifier is working properly. Rectifier function we have to check for functionality test, we call it, whether the current output is correct, the meter is showing correct current. Every 2 months you have to check. So this is closed book question. Yes, annual cathodic protection surveys are recommended to ensure the effectiveness of cathodic protection. The electrical measurement may include one or more measurement. That is closed book question. Then 11.3.2.2, all source of impulse current should be checked at intervals not exceeding 2 months, unless specified otherwise by regulation. Evidence of proper function may be current output, normal power consumption, signal indicating normal operation, or satisfactory electrical state. The next page, cathodic protection records, page number 45. Data pertinent to the design, installation, operation, maintenance, and the effectiveness of corrosion control measures should be documented in a clear, concise, and workable manner. That is open book question. The record should be in a clear, concise, and workable manner. That line, clear, concise, and workable. Okay, this is open book question. Then finally, 11.4.7, records sufficient to demonstrate the need for corrosion control measures should be retained as long as the facility involved is. So you have to keep the records in service. Records related to the effectiveness of cathodic protection should be retained 5 years. So records on the 5 years you have to retain it.
Yeah, sir, you mentioned me somewhere 1 year, right, sir?
That is cathodic protection survey.
Where it is mentioned?
Rectifier on the here. Every one you can see annual cathodic protection. 11.3.1.
So they're using annual cathodic protection survey.
Yeah.
Should be
Only every year we have to do survey.
Yes, sir. Yes, sir.
And impressed current every 2 months you have to check whether the rectifier is working properly.
Okay, thank you, sir.
Right, that's all. 651. Before going 652, we will go for questions so that we can attend the question. Then we'll move. We have more questions, huh? Generally, there will be asked a 6 question. I told you we have 62 questions, 10 times more. Okay, we will mark it. I think some are not marked. We will mark it. Yes, please. Each 15.
A form of localized corrosion initiated by the difference in metal ion or oxygen concentration due to previous deposit or difference in oxygen concentration.
It is not sharing?
No, sir.
Okay. Sorry. So answer is a form of localized corrosion. So where you have to check? You close this one. So answer also we will mark it if anything miss. So form of localized corrosion here. So concentration cell corrosion. The answer is here. So 3.10. A form of local initiated by difference in the metal in oxygen. That is the one now. A form of localized corrosion initiates difference in metal ion oxygen concentration. Okay, so answer is concentration cell corrosion. Okay. Next one.
An electrochemical shell with the electromotive force of which is due to a difference in
Okay.
oxygen concentration at one part of the tank bottom as compared with at another part of the tank bottom of the same material.
So what is the answer? Differential aeration shell, where it is given here. 3.16. Differential aeration cell. 3.16. Next one, please.
The loss of electrons by a constitutive of a chemical reaction is.
So loss of electron is called oxidation. So gain of electron is called reduction. So where it is given, we will mark it, because anything miss, you will check. Oxidation. Okay, the loss 3.3.4. Loss of electrons. Next one.
Shallow anode bed is a group of cathodic protection anodes installed individually, placed uniformly and typical.
Buried less than 20 feet. Shallow anode bed. 3.42. Shallow anode bed. Okay. Next one.
Deep anode bed is 1 or more.
Okay, answer is 50 feet. Deep anode, so it will be before, because D will be here. Okay, 3.15. 15 deep anode bed. 50 feet or more. Okay. Next.
A discontinuity in a protective coating that exposes the underlying substrate to the environment is
Holiday. Okay, that is no need to mark. We know that. Okay, next.
An electric current supplied by a device employing a power source that is external to the electrode system is
Impressed current. So impressed current, where it is there? GGH 3.29. Impressed current. The holiday is here. 3.28 holiday. Even though we didn't mark question, so okay, we'll mark it later, no problem. So mark it close book question. These are close book only. So mark it, this also close book question. Okay. The next one.
current flowing through paths other than the instantaneous circuit.
Stray current. That is the definition of the stray current. So page number 3.44, stray current. Stray current, intercurrent currents both are same. Okay, next.
According to API recommended practice 61, there are 4 components in each corrosion cell. These components are an anode and all but which are the following?
So anode, there is no, a cathode is there, electrolyte is there, metallic parts. So there is no DC current batteries. All but which are the following? These 3 are there. Cathode, electrolyte, metallic parts, and the anode is already there. So where it is given in the code book?
4.1.1.
4.1.1 second, this one. There are 4. These are closed book question only. Yes. Okay. Next.
The base metal goes into solution corrodes by releasing electrons and forming positive metal ions. This reaction happens at which component of the corrosion cell?
Corrodes by releasing electrons will be anode. Anode only there will be a corrosion. So if you take this one, this is the one, anode. Again, this is a closed book question. Yeah, this all you should remember. Okay. No need to formula. Next.
Which of the following is the most correct statement regarding the cathode?
Moderate corrosion takes place at the cathode. No corrosion takes place at the cathode. So cathode, there will be no corrosion where it is given. At the cathode chemical reaction, no corrosion takes place. Okay. Next one.
The electrolyte contains ions and conducts positive current from the anode to the cathode. The most common electrolyte for external tank bottom surface is, while the most common for internal surface is.
So I think external is moist soil. Internal will be water and sludge. Where it is given? The electrolyte cathode, the electrolyte contains both negatively. Okay. Last side. And the most common for external surface will water and sludge. This line. Okay. Next one.
The two most common types of corrosion to tank bottom are gas and S.
General and pitting corrosion.
And for the two most common type related to tank bottom are general and supply.
It is given here. Mark it. Okay, close book question. All right. The next.
This type of corrosion may only affect relatively small areas, while substantial areas of the surface are unaffected by corrosion.
Pitting. So pitting will affect only a small area. I think same paragraph. The individual corrosions are anodic. In localized pitting, the individual corrosions are anodic and areas in may concentrated within relatively small areas. This one. Small areas. Here, the last line. Okay, next.
Composition of the metal is a factor in determining which areas become anodes and which becomes cathodes. What else can cause corrosion?
So difference in the weld metal, heat effect zone and parent metal. So it is given here. So difference in this last line. Weld metal caused by heat effect zone and parent metal. 4.1.3 last line. Yeah, last line. Yes, next.
Which of the following is a correct statement regarding oxygen concentration of the electrolyte?
Oxygen electrolyte has no impact on the corrosion. No. Areas with lower oxygen becomes anodic and the area with higher oxygen become cathodic. So where the oxygen level is less will corrode more. That will become anodic. Where it is given here. Yeah. So mark it as a closed book question. Right. Next, what type of product may be stored? The type, rate of corrosion on a structure contact with the soil. So answer is this one.
What type of
Type and rate of structure and the contact with the soil. Where it is given?
4.1.9.
Soil can affect the type and rate of corrosion contact with the soil. So anything missing highlight, we'll highlight it. Next,
Another term used, what is ray current?
that is interference current. This was very important asked in the last exam. Stray currents also known as interference current.
4.2.1.
Yes. Okay. Next one.
Most common and potentially the most
Direct currents. Direct currents are because they are direct flowing one direction, they can cause more damage. So this is the one. The most common, most potentially stay this one, direct current. This line, close book question. Or 2.16 line. Next,
the following is not likely to be a source of
static electricity yielding. These are this one. Impressed current cathodic will not be the source of. No, check. Stay here. Next line.
these earlier
Including railroad, subways, welding, imprint also there.
Interest current also.
Yeah, that's why I have a doubt. Then what is the railroad, welding, static electricity?
Electric railroad, welding, same interest current.
This include the electric subways, welding, impressed current, and thermal. There's no static electricity in the list. See, the answer is static electricity. Welding machines are there, impressed current cathodic, and the railroads. Next,
metals with different composition connected in electrolyte is a general
galvanic corrosion. So where it is given. Next. So when two metals connected with the electrolyte, no. Next,
All but one of the following is listed as major factor. The influence of severity of internal corrosion. It is not a
factor, which is not the factor. There is a gap here. So what listed as the influence, the severity of intercorrosion, the pH level of the fluid, suspended solids, the amount of nitrogen, I think amount of nitrogen, where it is given the
4.3.
internal corrosion. Major factors influencing the corrosion include. That is a open book question. So what is given? Conductivity, suspended.
Suspend solid, pH level.
There is no nitrogen here. There is no nitrogen.
which is the
Amount of nitrogen.
suspended oil. Amount of nitrogen is
B, the amount of nitrogen in the fluid. There is no nitrogen here. Next, yeah, open book.
in soil corrosion controls by cathodic protection soil use. ASTs be provided.
In the initial design itself, when you are going for new tank, you even design, it is here. Okay, corrosion control infographic should be include the initial design. This line. Yeah. Okay. Leave it, no problem. Next,
cathodic protection is applied.
So it should be maintained during the service life of the tank. Completely at once you applied, it should be removed after 10 years, 20 years. There is no this one. Should be maintained after next line. Okay. If cathodic protection is applied, it should be maintained during the service life of the tank. So there are two questions here. Okay. Next.
Generally, tanks in petroleum studies use ash on the internal surface to control internal corrosion.
So cathodic protection in conjunction with coatings. Okay, where it is given. Okay, generally.
0.1.3 for tank in petroleum coating, internal cathodic protection in conjunction with coating can be used.
Okay, that is the one. Marked already. Next.
Evaluation of tank history should be performed prior to
Temporarily determining the need for cathodic protection. Determining the need for cathodic protection. A full evaluation tank is to be performed prior to determining the need for cathodic protection, where it is given. Okay. Here.
2.1 general.
Before determining the need for here a full evaluation of tank history is advised. Five point 2.1. Next.
What is an advantage of using fine particle of the fission material?
The fine particle and which makes it easier to transfer. No, fine provide denser to help reduce the influx and the outflow of oxygen. That is the correct. So where it is given, tank pad. Okay, here. The fine reduce the influx and outflow of oxygen. If you read 2 times, you can guess the answer. No need to. Okay. Next.
What is the main disadvantage in using large size particle?
The large may puncture the tank. No. The large trap moisture. No. Use differential aeration. Contact the tank bottom. So differential aeration cell will contact, because there will be a crevice portion here, large particle here. Same paragraph. Next.
While resistivity of about 1250.
So you have to refer this one. 125 moderately corrosive. Mildly or moderately? 1250 cm. So 1250 cm. Now this will be here moderately corrosive. Okay, this already we have highlighted. Okay. Next one.
Survey can be used to determine
Result of when it is time to replace the fission material need for cathodic protection. Yeah. So where it is given. Here. This line. 5313. The result of soil could be considered to help to determine the need for cathetic protection. 13. Right. So we'll continue where we left. Question number: the results of soil residue can be used to determine the need for cathetic protection. Yeah, that is where we left actually. Okay. Next question. Okay, next. Yes, please.
Properly designed concrete tank cushion constructed on stable, properly prepared subsoil, maybe effective in all but which of the following?
So a properly designed, constructed intrusion of effective need for cathetic protection. So where it is given, you can go here.
And
So if you go to the sand pad, no, this concrete cord or this one? A properly included concrete tank cushion. It is about the concrete tank cushion. Yeah. Okay. So this is need for cathetic protection. 5.3.1.1. A properly designed, constructed on stable, properly prepared subsoil may be effective in elimination, intrusion of groundwater, soil side erosion, and need for cathetic. No. It may be effective in all but which of the following: cracks in the tank bottom weld seams. This is the answer. Okay. This all need for this are this one, except this one. Okay. Yeah. Cracks for the tank bottom. It will not be cause cracks for the tank bottom.
Where did you showed me, sir? Can you come again, please? Where was the answer, sir?
This one. 5.3.31. I think it is sharing. Yes.
Yes, sir.
A properly designed concrete constructed on stable, properly prepared subsoil may be effective in eliminating intrusion, soil side erosion, and the need for cathetic protection.
Okay,
So
sir.
this will eliminate, may be effective in all but which are the following except this.
Okay,
Yeah.
sir.
Next one, please.
Corrosion of the steel tank bottom installed on a concrete cushion may result from moisture accumulation caused by all but which of the following?
So corrosion of the steel tank bottom, concrete, condensation, blowing rain, humidity, flooding. So let us check which one is the correct.
Snow, flooding.
All the prevented by that means still the collection of moisture between tank bottom due to condensation, blowing rain or snow, flooding due to inadequate rainwater. So these are the answers. So which one is answer? Condensation, humidity in the air surrounding the tank. So all others are answers. Next.
What is the most common material used as a cushion storage tank bottom?
So clean sand. Okay. So where it is given, I think here. Sand is often no. Okay, here 5.3.2. Clean sand is the most common material used as a pad beneath above ground storage tanks. 5.3.2. 3.2, section 5.3.2, first line. First line. Sand is the most common material used. Yes, next one.
Sand is often installed by loose lift in maximum layer of
So 6 to 8 inch. This is important question. So here it is there. So 5322B,
5.2.2B.
okay, 6 to 8 inch thickness. Okay. Then next one. Okay,
Where a layer of cushion limestone or clam shell is used for tank cushion. Why it is important to ensure the particles are fine and uniform.
large particles puncture, no, differential aeration will cause fitting in the between the large particles under the metals. Allow formation of dissolved gas packets, I think this one. So limestone and clamshell, you can see here. Okay. Since the differential aeration will cause fitting area contact with the large particle and the metal, this one.
5.3.4.
Yeah, second line. That is another one, 2 questions. Okay, next one.
Heated tank or tank storing hot water can cause.
So heated tanks, oxalator corrosions, especially in tanks with water bottom, the excessive drying out of concrete resulting external surface. So I think accelerated corrosion on the internal surface, especially tanks with the water bottom. So heated tanks or tanks storing hot products can cause. Okay. Where it is given?
1.4.1.
Okay. So bottom, yeah, sorry, there is the external surface of the bottom tank. We marked the answer wrongly. So this one. External surface of the bottom of the heated tank. So the correct answer is not this one. The axial corrosion external surface due to the elevated temperature. Okay. Okay, next.
The corrosion rate of the steel may, as with every 18 degrees.
Double. Every 10 degree over 25, it may be double. So the next slide. The note. Yeah. Next one.
Where on the galvanic series is clean and shiny mild steel.
So clean and from table you have to refer it. Mild steel will have minus 0.5 to 0.8 volts. So you have to refer this table. Okay. Yeah. This is an open book, no problem. Next question.
What are the two systems of galvanic corrosion?
So galvanic corrosion and impressed current. Okay, no need to mark. Next. The most common metal used for galvanic anodes, magnesium and zinc. That is a closed book question. So if you say metal common anodes are magnesium and zinc in cast or ribbon form. This one. 6.2.1, fifth line. Then next one.
Of the following, which is not an advantage of galvanic cathodic protection system?
No external power is needed. Advantage. Capital low and advantage. Low use of no. This is the limitation. Method is low resistivity soil only. That is a limitation. It is not advantage. You can see disadvantage. It is marked. So galvanic advantage, disadvantage. Limited to low resistivity soil. Yeah, that is a disadvantage. Open book question. That is not an advantage. It is limited to only low resistivity. You can use it. High resistivity we cannot use it. Okay. Next one.
Impressed current cathodic protection system are.
Direct current usually provided by a rectifier. Direct current usually provided by a rectifier. So where it is given, impressed current directly provided by the rectifier attached to the AC source here. 6.3.1 second line.
Interest current system or direct current.
attached to an AC power. That is a closed question.
சார் புக்கே படிக்கணும் போல இதை பார்த்தாலே ஃபுல்லா போயிடும் போல.
Okay, right. Next.
லேண்ட் பேர்ல எல்லாமே இருக்கு சார்.
ஆமா. Which is the advantage of impressed current cathodic? High current output, high operating cost is a disadvantage. High maintenance cost. So high current output is the advantage. Others are disadvantage. High capital cost, high maintenance cost, high operating. These are disadvantage. Only high current output is the advantage. So this is an open book question. When they are asking high current output, mark it as a open book. Okay. A cathode production requires two major components. What are they? So what are the major components? A step-down transformer to reduce the AC supply voltage and rectifying elements. Convert not DC to AC to DC actually. You have to reduce the AC power supply voltage and rectify convert to AC. The answer is B. Where it is given, you can see here. 6 point. Here. Here, typical cathodic production has two major step-down transfer, reduce the AC and rectify elements to convert AC to DC outputs. This is the open book. Yeah. The next.
Interest current anode used this while are not made of.
Not made of, they can use graphite, high silicon, mixed metal, zinc. They are not using the zinc. So where it is given, so what they made of, they have given actually.
Yes, 6.3.5.
6 point,
Graphite.
okay, graphite, we are using this one. Graphite, scrap steel, high silicon, aluminum. Okay, there's no, this one. That's an open book question. Next one.
In partial galvanic steel, use of the coming material more cathodic.
More cathodic. Cathodic means which is having a high protection. Magnesium will have more cathodic. So we have to, again, we have to go back to the table. So the commercially pure magnesium is the more cathodic.
Commercial pure.
But it is minus 1.7. What is given here?
Here also minus 1.
Okay, correct. Cathode na protective ending. See, cathode is the protective ending. This is the more anodic. Oh, sorry. It is wrong. Carbon is a more cathodic. Point plus 3. This is the magnesium will corrode. It is anode. This is the cathode. So answer is wrong. 0.3. Carbon.
Carbon.
Potential of plus 0.3. Okay, next.
Which of the following are disadvantages of closed current system?
So safety aspects are negative lead connection, more frequent monitoring, loss of AC power, all of the above. I think so. Which are the, yeah, impressed current disadvantage.
Possible interference, loss of AC, higher maintenance, higher level for service.
So possibly interference, higher maintenance, safety aspects of rectifier location. This all open book question. Check all are there. 1 minute, I will show you the. Okay. So all are there. Safety aspect.
Loss of AC.
More frequent monitoring is there.
More frequent. Yeah. G, sir.
D for more frequent monitoring also there. Okay, all of the above. Next.
Which rectifier are more efficient?
Silicon. So you have to use a silicon rectifiers. So where it is given here. Silicon rectifiers are generally more efficient. Yeah, 6.3.4, third line. Next,
API 651 provides criteria for determining the adequacy of pattern production of overground storage tank. What document is referring for more detailed discussion?
so NACE RP 193, where it is given.
Production criteria 8.2.1 NACE RP.
So it is given in 8.2.1. Okay, right.
In determining if adequate calorie production is being achieved.
So a negative potential of at least 8 mil with cathodic current is applied. Okay,
850 MV.
850 MV. A positive
A negative calorie potential of
850 millivolt. So answer is A, where it is given here. A negative 8.2.1. Next one, how much cathodic polarization?
100
Millivolt. So polarization 100 millivolt.
6.2.2.
A negative polarization at least 100 mill. Sorry, this one. Next,
Name a common method of measuring polarized potential.
using a instant off method. Suddenly they will switch off and check it. Instant off method. Yeah, where it is given this paragraph. Just now highlight. One common method of measuring potential using a instant off technique. Open book question. 8.2.2 second line. 2.2 second line. One common method of measuring the polarized potential by using a instant off technique. Yeah, here. Next.
The standard method of determining the effectiveness of cathodic protection on a tank model.
So tank to soil potential, where it is given. The standard method of cathodic protection tank to soil potential measurement. 8.3.1 first line. Next one.
How is the tank to soil potential measurement performed?
This measurement performed using a low impedance voltage less than 10 ohms. The measurement is performed greater than 10 ohms. Okay. And now what is the next line? Reproducible or regenerative? High voltage greater than and a reproducible reference electrode. So this is the line. Reproducible reference electrode contacting the electrode. So it is a reproducible contacting the electrode. Okay. Next.
Correction of IR drop in the soil is often necessary for measurement made at the tank perimeter. Then the reference electrode is placed immediately adjacent to the tank. This is a specific rule if that's been
Distributed anodes, where it is given correction for IR drop 8.3.3. Okay. At soil necessary measurement made, this especially distributed anodes are closed. Right. Next.
other standard reference electrode may be substituted for the saturated copper as copper sulfate reference electrode is not a common tool.
So we can use zinc is not, I don't know what is aluminum, which is not in the list. There is a table. KCl, silver, zinc. We are using KCl, silver, zinc. So KCl, aluminum is not there.
Silver is there, zinc is aluminum.
Aluminum is there? No, no.
No.
No aluminum. Okay. Okay. Right.
Measurement of the native structure evaluation to be made.
Immediately after the any catheter system is energized, prior to energizing the new catheter protection system, measurement of native soil. So it is given in okay. Here 11.3.1. Prior to energizing new measurement of the native to potential should be made. First line. Next.
After the system has been analyzed, it may be take gas from a steady state routine.
So after the energized may take several months. So answer is this one. Okay, next.
To ensure the effectiveness of cathodic protection. How often,
So how often we have to use cathodic protection? Annually. Annually. So annually is given here. Annual cathetic protection. Okay, next. Here 11.3.1.2 annual cathetic protection. Next, how often should all source of infrared current not exceeding 2 months? 2 months. So not X 11.3.3.2. Records to demonstrate the need for correction should be retained. No, records to demonstrate the need for correction.
5 years.
Here,
5 years. This is sort of large.
no, records of it demonstrate it should be done as long as the facility. So there are two things here. Records sufficient to demonstrate the need for records related to the effectiveness 5 years. See whether first line there is a difference between first and second line. First line what it says, records sufficient to demonstrate whether need for correction, why we need cathetic protection should be rated as long as the facility effectiveness of the cathetic protection. That means whether cathetic protection working effectively should be 5 years. And finally, records ready effectiveness of cathetic protection 5 years. So almost we cover most of the code book. Question
61 coming in, sir. Orange, sir. 61. The records to demonstrate for corrosion control measurement should retain the.
Demonstrate the need for corrosion control. See, it is here.
Yes, sir. Yes, sir. First
Records
line.
sufficient demonstrate the need for corrosion as long as this.
Okay, sir. Okay, sir. Thank you, sir.
Okay.
5 years.
Right. So everything is correct.
100%.
Okay, because we see worked with book. Okay, that is the end of 651. So please take 652. Please take 652, a small code book. There is no 652.
All things up or sequence?
No, mix up only it will come.
If there is no need to then
Right. Now, linings. Again, so where we are using the internal linings. Linings above the above ground. First one, where we are using the linings. Linings are used in the inside of the tank to protect the product side corrosion. So soil side corrosion, we are using the cathodic protection. Regarding linings, we should know there are three types of lining. One is called thin film lining. Second one is thick unreinforced lining. Third one is thick reinforced lining. So thin film linings are just painting only. They will use a multiple spray, which can be removed after, because once they become solid, you can, if you want, you can remove it. Thin film linings, same like what you call that galvanic and impressed current. Thin film lining is similar to galvanic. What are the advantage of galvanic? Application is simple, low cost, maintenance cost is low. But what is the disadvantage of this? Okay, because it will not work for a larger tank. Same way, thin film linings, application is simple, removal is simple, cost is less. Okay, but even MFL we can do over the line. Thin film lining, it will not, no need to remove the lining for MFL. Suppose there is any corrosion happening bottom side, with the lining you can do MFL, magnetic fluctuation. But what is the disadvantage of thin film linings is they are suitable only when you are installing on the new tank bottom, because we need a smooth surface. If it is a corroded old tank, it is corroded, there will be a lot of perforation, holes are there. What will happen? They will make a hole on the hole will if it's anything sharp edges will make a hole on the line. So they are not suitable for a old tank. Okay, but if the thin film lining is properly applied, they can come for 20 years at least. Generally, they will come up to 20 years. First of all. Second, thick film unreinforced lining means we are using a multi-course, making a thick. So what is meant by thin film and thick film? Based on the thickness of the line, 20 mils, less than 20 mils, thin film, 20 mils and more thickness of the line. Unreinforced linings are not generally preferred because they don't have not much advantage. But if you are going for thick film lining, we have to go for reinforced. Reinforcement, you will use some mattress fabric. Over that, we will line it. Okay, that I will show you the video. That is called a thick film reinforced lining. What is the advantage of thick film lining? They can be used as a new tank as well as a old tank. Even the surface road, because of the we are using chopping mattress, it can be withstand. But what is the disadvantage of that? The lining can come to 30 years, it can come. The life is 25 to 30 years. Now, what is the disadvantage of that lining is expensive. Maintenance cost, everything is expensive. I will just to go through the video, YouTube video, then we will check. So there is no sound. This is off. 1 minute, 1 minute, 1 minute. Okay.
To above ground metal storage tank.
Okay.
Chemicals can be severely corrosive to above ground metal storage tanks, resulting in possible leaks. The average corrosion rate of some carbon steel storage tanks in certain surfaces at ambient temperatures is more than 1 mil per year, with leaks developing in as few as 5 years. These leaks result in costs for both tank repair and possible environmental penalties. Tank corrosion sometimes increases when a layer of water containing soluble salts and chloride settles to the bottom. These compounds are highly corrosive in themselves, and they can generate a strong electrolyte that further promotes corrosion from within. There can be a problem with external tank corrosion as well. The bottoms of above-ground storage tanks are susceptible to corrosion, especially if the tanks are close to salt water or subject to stray electrical currents in the soil. If an above-ground tank bottom is corroding, it must either be replaced or coated with a thick film, fiberglass reinforced lining with a 60 to 65 mil dry film thickness. Since replacing a tank bottom can be costly and time-consuming, fiberglass linings have become a popular alternative for tank bottom repair. GRE lining is a significant application in the fiberglass industry. It has diverse applications including corrosion resistance, structural strengthening, and waterproofing. GRE lining applications can be done not only in water storage tanks but also for sewage tanks, chemical storage tanks, crude oil storage tanks, tank roof lining, sewage sump pits.
This is a mattress. They will place it and they will poke a
chemical
lining.
plants, and fire
That is called a
protection
reinforcement.
networks. The recent
Yeah,
trend
this is a
has
reinforcement.
municipalities shifting away from replacing tank bottoms and toward the application of fiberglass lining systems where recommended. Installing a lining system means applying a primer, catalyzed resin with a glass pad, tissue, and a seal coat. The tank must be dry and the surface properly prepared. The entire process is quicker and less expensive than replacing an entire tank bottom. A properly selected and applied lining can protect the steel from internal corrosion up to 10 to 20 years. Thick film fiberglass linings are considered secondary bottoms that are bonded tightly to the storage tank. When properly selected and applied, they prevent leakage due to internal corrosion for 10 to 20 years. If the supporting steel bottom is perforated, these linings also can help minimize the problem of exterior corrosion by providing enough strength to bridge small perforations. Even if severe corrosion is present on the outside, it is possible to apply a double layer of the laminate for a total thickness of 110 to 120 mils. Linings of less than 20 mils dry film thickness will not protect against leakage from outside corrosion. They are recommended only for relatively new tanks with no internal.
Less than 20 mil thin film, that is for new
corrosion.
tanks only.
This picture shows the fiberglass lining application in an external floating roof crude oil storage tank. In crude oil storage tanks, lining will be applied in bottom and first shell cores. Because the crude oil contains highly corrosive water which contains hydrogen sulfide and other solid contaminants. Based on numerous applications over the decades, these systems have a proven history of successful performance.
Okay.
This is for fiberglass.
Yeah.
Bitcoin has made headlines over and over again because it has repeatedly hit new all-time highs. Even so,
Last video was made from the
Chemicals
glass
can be
fiber.
severely
Yeah,
corrosive
lining,
to
yeah.
above-ground metal storage
One minute,
tanks,
1 minute, 1 minute. Okay.
resulting in possible leaks.
Just hold on.
The average corrosion rate of some carbon steel storage tanks in certain surfaces at ambient temperatures is more than 1 mil per year, with leaks.
So we have one more video about the
some new type.
Yeah.
It's not possible.
Yeah, well, this is the old tank. This is for old tank. Okay.
Welcome to ABFAD's FuelVac double skin tank lining system. The FuelVac system offers a comprehensive and complete answer to the age-old problem of tank corrosion degradation. Welcome to ABFAD's FuelVac double skin tank lining system. The FuelVac system offers a comprehensive and complete answer to the age-old problem of tank corrosion degradation, dispensing with the need for expensive floor plate replacement or a new tank. First, the existing tank is prepared for grit blasting to Swedish standard SA 2.5. After blasting, any bacterial corrosion becomes apparent and can be repaired by applying epoxy engineering compounds. During the next stage, the first protective coating layer is applied. A solvent-free resin is sprayed to a thickness of 1000 microns nominal thickness. A Hydrocat plural component heated spray pump is used to apply solvent-free coatings, which provide long-term protection for steel and concrete. After the initial base coating is applied, the double skin lining materials are installed. ABFAD's FuelVac has been designed to follow all contours continuously throughout the tank to give one seamless interstitial space, which can then be vacuum pressure monitored. Once the double skin lining is installed, the first coats are sprayed to complete the installation. To date, our double skin liners have been installed in tanks ranging from thousands to over 2 million litres, proving that any size tank can be double skinned.
So this is a holiday test.
Using the Class 1 vacuum pressure leak detection equipment means that expensive downtime for internal weld, seam, floor and wall inspections is minimized, as the tank lining vacuum is monitored for any vacuum loss. The vacuum monitoring equipment installed can be connected to a variety of software systems.
These are not important. These are their technical. Okay, so please take code book. We'll continue with the code book. 652. Again, there will be around 6 questions. It is revised in 2020 with a lot of corrections. Okay, almost they changed the entire code book. Right. Okay, so we'll go through the book. Please go to the terms and definition. So, how to clean the surface for lining? Generally, it need a white metal blast cleaning. White metal blast cleaning is covered in NACE number 1 SSPC SP5. This is a page number 2 close book question. Or sometimes at least near white metal blast SP10 we have to follow. Okay, then FRP linings are covered in PA6 SSPC and PA8 thin film organic linings are covered. This standard issue, no, they are referenced in the main code also. Then what is meant by anchor profile or anchor pattern or surface profile? How much roughness is required before applying lining? The surface, it is same like a painting code almost. So before painting, you have to prepare a surface contour or roughness of a blast clean substrate surface when viewed from the edge. Okay. Then what is concentration cell? I think this is a repeated one. Electrochemical cell, the electromotive force in which is caused by a difference in concentration of some electrolyte. Then what is corrosion? It was asked in closed book question. the chemical or electrochemical reaction between a material, usually a metal, and its environment that produce a deterioration of the material and its property. That is called the definition of the corrosion. That is a closed book question. Then curing. So we have to dry this lining once applied. That is called curing. The process whereby a liquid coating becomes a hard film. Curing is complete when the lining is ready to accept the immersion in the designated surface. So after curing completion will be only we will start filling the tank. The differential aeration is the same. A concentration caused by difference in oxygen concentration. Then electrolyte. A non-metallic substance that carries an electric current or a substance which when dissolved in another medium in water separate into ions. That is the electrolyte. Then this is important. What is meant by epoxy? Open the question. Extremely tough and durable synthetic coating resin that are highly resistant to chemicals, abrasion, moisture. So generally, thin film linings are made, epoxy paint, epoxy means almost thin film linings are made up of epoxy. Epoxy. FRP lining, fiber reinforced resin linings, usually polyester, vinyl ester, or epoxy, in which layers of fiberglass are incorporated in the lining structural capability and performance as per SSPC PA6. That is called FRP lining. Then what is meant by fretting corrosion? See, fretting corrosion means when there is a movement in tank where we will expect a fretting corrosion, you know, the floating roof. Floating roof will have a floating legs. When the roof is coming down, the legs will sit on the tank bottom. When they hitting the tank bottom, they will remove any coating in the bottom. That is not lining, that is any paint. It will remove and that area may corrode. But every time, then once the corrosion is over, every time they will hit, they will expose the area for further corrosion. That is called fretting corrosion. Where fretting corrosion will occur when the open pipes of the or legs of the floating roof contact on the tank bottom. Okay. Deterioration at the interface between contacting surfaces as a result of corrosion and movement between the two surfaces. Holiday, a discontinued the protective coating that exposes unprotected surface to the environment. Also refer to the application defects where a small area left uncoated. And what is mil? 1/1000th of an inch. That is 1 mil is equal to 0.001 inch. 1 mil is equal to 25.4 micrometer. 1 mil is equal to 25 micrometer. Mill scale. What is mill scale? The heavy oxide layer formed during hot fabrication of heat treatment of metals. Typically a black blue colored smooth layer found on the surface. That is called mill scale. Then phenolic, a resin of phenolic formaldehyde type. Primer. First complete coat applied to the prepared surface. That is called a primer. Then these two are very, very important. Regularly asked the exam. What is meant by thick film lining? A lining with a dry film thickness of 20 mils or more thick film. Less than 20 mils, we call it as a thin film. Then volatile corrosion inhibitor, VCL. What is VCL? A type of corrosion inhibitor that is used to protect ferrous metal and non-ferrous metal against corrosion and oxidation where it is impractical to apply surface treatments. It works by slowly releasing the chemical compounds within the sealed airspace that is called volatile corrosion inhibitor. Water bottom. A water layer in the bottom of a tank caused by separation of water and produced due to difference in solubility and specific gravity. Now we'll go to the corrosion mechanisms. So we have chemical corrosion, concentration, not everything. Just to highlight this important only. Chemical corrosion. First line, chemical corrosion may occur in environmental and product cleanup tanks as well as chemical storage tanks. First line only important. Then concentration shell corrosion, highlight 4.3, first two lines. Concentration shell corrosion may occur when the steel tank bottom is in contact with the electrolytes that contain different substrates on the same substrate in differing amounts. Then concentration shell corrosion will cause pitting and may result in significant localized metal loss. Pitting of a bare steel tank bottom may occur at a rate of 80 mils per year. That is important. Close book question. Then oxygen cell corrosion. Oxygen cell corrosion may occur when surface deposit mill scale or crevice create a localized area of lower oxygen concentration. That line is important. Because of the deposit, if there is a gap between mill scale and the bottom, then there will be a less oxygen. Then galvanic cell corrosion, second paragraph. In some cases, welding can produce a large difference in the microstructure of a seal bottom plate, resulting in a built-in galvanic couple. In the presence of a corroded electrode, preferential corrosion can occur in the heat affected zone. Sometimes weld will not corrode, heat affected zone will occur because of the different metallurgical process. Then MIC, first paragraph, last line. The mere physical presence of bacteria deposit can promote aggressive pitting corrosion by concentration shell mechanisms. That is important. The metabolism of bacteria is important regarding the corrosion of storage tank bottom. Most bacteria found in the petroleum industry strict anaerobes that do not proliferate in the presence of, they don't need oxygen actually. However, the dense bacterial colonies create a local anaerobe. Then the fifth line. Moreover, the iron sulfide corrosion products is cathodic. If there is an iron file layer formed, it will protect the tank to the base metal and may promote auxiliary pitting corrosion by galvanic. Erosion corrosion. What is meant by erosion? It is removing the metal. Where erosion will happen on the inlet because of the high velocity. Highlight this one. Erosion corrosion may occur in the wastewater treating and mixing where the soil and small abrasive aggregate is present. Erosion can occur in the tank mixture, a water treatment brush. So this is occur in the mixing tank at the inlet point. You can see here the first two line. Erosion can cause highly localized metal loss in a well-defined pattern. Erosion corrosion may be found in tank inlets and outlet where product flow. So for erosion corrosion, we need a flow. Fretting, I already told you, fretting rate may occur in the hydrocarbon that bottoms of external floating roof tanks. Then the fourth line, repeated frequent contact between the striker plate and the open end of the pipe plug removes any protective layer or rust scale and that may be formed on the striker plate surface. When the roof is floated again, any water on the tank bottom causes corrosion at the location of the striker plate. Then stress corrosion crack. Highlight this one, 4. Stress corrosion cracking has been identified in tanks storing fuel grade ethanol. Owner operator should take measure to protect wells from this phenomenon. One method identified to prevent SC is to coat wells with the internal lining materials. That line is important. How to prevent stress corrosion cracking? We can quote this one. There should not be no contact between the corrosion product and the stressed one. This would typically include bottom and lower shell wells, which are coated when complete bottom is coated. Then determination of need for tank bottom lining. See, you remember 653? In chapter 4, 653, we calculated, say, shell calculation, that is 1 foot formula we used. Bottom, we used a formula MRT. What is MRT? Minimum remaining thickness at the next inspection, interval OR. What 653 says, MRT should be at least 0.1 inch. But if the calculated value coming less than 0.1 inch, you have many options. One of the option, repair the tank bottom, retire. Another option, or replace the tank bottom. Another option is go for lining. Or one more option is go for cathodic protection. So when you go for cathodic protection, the bottom corrosion rate will be 0. Effective. If you go for lining, top side corrosion will be 0. Okay. There is one more condition. There is one table 4.4 in 653. If you are going for a thick film lining, more than 50 mils. See, as per 652 code, anything more than 20 mil is considered as a thick film. But if your thickness is more than 50 mils, the MRT, minimum remaining thickness at the next can be half of the 0.1 inch. That is half of the 0.1 inch, 0.05 inch allowed. That is advantage. That means you can increase the inspection interval because 0.1 inch it is coming 10 years. When it will become 0.05, 20 years. Double. Okay, so you can increase the, that is the advantage of going for a thick film line. Okay, highlight this one. Storage tanks bottoms are generally fabricated from carbon steel section, typically less than 0.25 inch. Next line is important. Annular bottom plates of storage tank frequently have thicker plate section from 0.25 to 1 inch. The bottom plate sections are the attachment fillet lappers are intended to function as a members and to prevent leaks. Then the need for tank bottom lining in an above ground storage tank is generally based on several considerations. This is open book corrosion prevention, tank design, tank history, environmental, reduction, federal state rules, all these things. Now, 5.2 linings for corrosion protection, second paragraph. The minimum thickness of the steel tank bottom should be determined according to 653. An internal tank bottom lining may be deemed necessary if corrosion is expected to proceed such that steel thickness may reach as a minimum generally 0.1 inch prior to the next inspection. That is the minimum remaining thickness. If it is going to be less than 0.1 inch, you have to consider the lines. That is what close book. Then these are not important. Please go to the page 5.4, page number 10. Tank foundation. The foundation must be adequate to prevent excessive settlement of the tank. If uniform foundation support is not provided, fluxing of the tank can result in the tank is if the tank is filled or emptied. Fluxing occurs on all steel bottoms. However, excessive fluxing may cause internal bottom lining to crack. If the bottom plate is making fluxing, bend and lining will break. Lining will break off, particularly thick film lining. The tank bottom lining selection. Highlight this one. Tank bottom lining is generally divided in two classes. Thin films with a DFT. DFT means dry film thickness less than 20 mils, or the thick films with a DFT 20 mils or more. Linings may be applied to the bottom of storage tanks when they are first constructed, or they may be installed after some period of service. Same like cathodic protection. Then inorganic zinc and zinc silicate. It is a separate one. It is separate lining, not thin film, thick film lining. It is spray, like a spray painting, where we are using generally ethanol storage tanks. Only the ethanol, methanol storage tanks. We will not, they are organic. We will use a inorganic zinc silicate lining. This section is ordered only in the latest revision. If you see previous 650 revision, this is not covered. So it may be asked in the exam. Inorganic zinc, IOZ, also known as zinc silicate, is a type of coating that can be used as a tank lining for ethanol and methanol storage. That is very important. We are using inorganic only for ethanol, methanol storage. Second line, IOZ is different from organic coatings in many respects. IOZ is typically applied to 3 mils to 5 mils in DFT. That line is important. It is applied only in one coat and relies on moisture for curing and must be applied by a spray process. IOZ chemically bonds the steel substrate into a different manner from organic. See, what is this one? Because we have a zinc, will react with the steel actually by galvanic process. In common with organic coating, IOZ should be applied after SP10 near white molasses. Okay. What is the advantage? The nature of zinc metal in the coating and the lack of organic binder result in indicate the metallic bond between the zinc, and there will be a metallic bond between the zinc and steel. Excellent adhesion. It will stick to the, can be applied at much lower temperature than organic. Almost immediate curing at ambient temperature. Preferred product by manufacturer for internal lining of ethanol and methanol. So if there any question asked about the ethanol, methanol storage, only inorganic zinc sulfate. That's all. This is nothing to do with the next line, thick film, thin film lining. They are entirely different. The disadvantage, it is only able to apply to one coat application, does not a foot adhesion itself. So only one coat you have to apply. Then if the application is too thin, less than 3 mils, there is inadequate protection of the steel. So it should be applied in 3 to 5 mils. Then C3 is important. Because IOZ catechins are metallic pigments and electrically conductive, they cannot be tested using the Holiday test. Because they are conductive materials, this paint coating is. So Holiday test is not possible. Both the low voltage and high voltage test equipment rely on internal lining electricity non-conductive. Then these are not important. These are not important. Now we'll go to the thin film tank bottom linings. Highlight the first line. Thin film tank bottom linings are frequently based on epoxy or epoxy copolymer resins. So thin films are like painting only. It is a epoxy line. Then which one we have to follow? NACE number SSPC PA8 should be given consideration when designing and installing thin film lining. So we have to use the SSPC PA8. Advantage. How to apply lining, everything is covered later. Thin film linings are often used for application of product side of the bottom of new storage tanks. Very important. Thin film lining we are using for, say, inorganic zinc silicate is for ethanol, methanol storage. What is the thickness we are applying? 3 to 5 mils. But thin film means less than 20 mils. 20 mils more means thick film. Thick film we have to unreinforced without a mattress. It's the reinforcement with the mat, with the fibers. New steel plates provide a smooth surface that can easily made ready for lining application. Corrosion of bare tank is rarely uniform. Generally, corrosion, these are not important. First two lines are important. Then the advantage of thin film. Initial cost is typically less than the reinforced thick film. So cost is low. Then easier to apply. Same like this one. Has shown that the word properly, this is close book question. It can come more than 20 years. Thin film lining will come up to 20 years. Thin film epoxy are good flexibility, more accurate MFL. So you can do MFL because of the low thickness. Easier to remove. Just we can peel off. Remove easier. The disadvantage, you remember 653 allows 0.05 inch only when the thickness of the lining is more than 50 mils, 0.05 inch. Thin film, that advantage is not there. See, 653 only allows bottom plates at the minimum 0.1 inch at the time of next inspection interval. Thin film line are more successful mechanical damage, easily damaged because of the low thickness. Rough weld surfaces, weld spatter, sharp component edges or corners, and rough or sharp areas can protrude weld into the finished lining thickness or create lack of edge retention. Okay, no problem. Continue. Huh? Okay, these are not important. Then we'll go to the thick film unreinforced lining. Thick film unreinforced lines may be used at tank bottom for both the new and the existing. Highlight that line. 6.4.1. Then what is the advantage of some thick film lining can be built up to 100 mils in single coat. Thick film means multiple spray. Better film built over rough surface. Rough surface also we can use it. But a disadvantage may require use of plural component, difficult to install on complex geometry due to plural component application. That is important. Open the question. Then we'll go to the reinforcer. See, thick film lining, generally they will go for reinforcer only. Without unreinforced, very rarely used. There are currently two systems being specified to restore the heavily corroded fitted FRP, fiberglass plastic laminates, and reinforced thick film lining. FRP laminates and reinforced thick lines are method to extend life of the stamp bottom. FRP system consists either a 1.5 ounce glass mat or chopped fiberglass roving embedded in a resin, that is open coupon. Typically either polyester, vinyl ester, or epoxy. So thin film linings are epoxy and epoxy. This one here we are using vinyl ester or polyester. Huh? Yeah, thin film reinforced. Then these are not important. Please go to the next page. Third paragraph. One coat application also enhances the tank turn-on time and remove the intercoat adhesion issues commonly with the improper install laminates and wicking issues. So if you are applying one coat, so what is the advantage of one coat means? Okay, there is no enhancer, easily adhesion. Easily it will adhere. Adhesion what trigger? Sticking. Adhesion. Reinforced thick film lining manufacturer typically recommend heated plural equipment for proper application. Generally, they will recommend for multiple applications. Plural or multiple. And both are applicable actually. Any of the above system described are suitable for tank bottom restoration when poor steel conditions are found. So you can either use for a single coat or you can go for a multiple lining also. Then advantage, System are designed to optimize the lining structural capability. Additional, so it can come up to 35 to 40 years. Small damage can be easily repaired. Some formulation are fairly wear resistant. What is the disadvantage? Yes, please.
So what's the difference between reinforced with reinforced line?
Reinforced lining will have this one, what you called chopped fiberglass.
Okay, sir.
Unreinforced means only multiple coating.
Okay, sir.
There is no chopped fiberglass. அந்த இது மாதிரி போட்டாங்கல்ல லேயர்
ஆமா,
மாதிரி
sir.
அந்த
Okay.
லேயர் இருக்காது. அதான் reinforcement.
Okay, sir.
Okay.
Thank you, sir.
Systems are designed to optimize lining structural capability. That is advantage. Additional surface life. Okay. Disadvantage, initial cost is higher and more difficult to apply. Must take additional safety working around the glass mat or chopped fiberglass. Gloves should be cut as well as chemically resistant. Applicant time curing with the integrator promoter, so we have to give the cure time. Then higher degree of expertise needed to avoid from layup. So we need expert people for this. These are, then highlight the 7. MFL and other scanning methods including UT are more difficult through a reinforced thick line because MFL is very difficult to do. UT we have to remove it. Then FRP laminates and reinforced can be much more difficult to remove and repair or replace compared to thin film and thick film. And so very FRP very difficult to remove. Temperature. So what temperature we have to apply it? See, temperature, humidity, and surface preparation, these are important factors. Temperature must be considered during selection of an internal lining system. Internal, suppose you have heated tank, the lining selection should be what is the storing temperature, what will be the humidity inside, what product you are going to store, because the lining should not react with the product. Otherwise, the lining will start dissolving, which are used to heat product maintenance viscosity, limit tossability to the tank bottom. Then this line is important. The owner operator should always consult the manufacturer for coating selection, suitable service, temperature limitation, and the curing schedule and the testing process. You have to follow manufacturer recommendation. That is open to question. Then please go to the next page. Presence of tank internals. Page number 17, 664, the last 4 lines. When electing to terminate a coating on a bottom or reinforcement at near a component, it is important the surface preparation performed to specification beyond the location. The coating should be terminated on the reinforcement not less than 2 inches from any weld. So for example, so this is your bottom, and when you are applying bottom lining, it will be terminated like this. So you will apply the complete bottom lining. Then it will be terminated here. A 2 inch at least on the shell. It will not stop here bottom. Like same our the tiles along triangular cutting. Same we have to this one. Okay. Vertical we have to cover it in the at least 2 inch on the any away from any point. Right. Then these are not important. Then please go to the next page. These are not important. Please go to the page number 19. 196733, last paragraph, not previous paragraph. Many locals require ethanol tanks to be decommissioned and repaired or lined during winter months. Most organic coatings cure best at 50 degrees Fahrenheit and above. So curing should be carried out 50 degrees and above. Then stress coercion cracking of and ethanol storage. Yeah. In addition to application of protect line to welds to mitigate the SCC, the act of abrasive plastering has been demonstrated to relieve the stress. Sometimes when you are using abrasive blasting like sand blasting, it can relieve stress also. Because the abrasive blasting is required to achieve the surface cleanness required for the internal, one unintended consequence of process is stress relief of the weld. It can relieve the stress because we are using the force. Yeah. Yeah, abrasive blasting like grit blast or sand blast can relieve the stress sometimes. That is an additional advantage. Historically, inorganic zinc has been the lining choice of ethanol. We will use only for ethanol or methanol storage. Then we'll go to the some general surface preparation. This is very, very important. The second paragraph here. Generally, abrasive blast cleaning to a white metal finish, NACE SSP S5 is desired. So white metal finish SP5 is preferred, but at least SP10 we have to follow. Abrasive blasting to near white metal finish, SP10 is often specified as the minimum degree of surface cleanliness. So SP5 white metal blast cleaning is the preferred one, but at least we have to go for near white metal blast cleaning. For small areas, suppose there is no access, we can go for a mechanical tool cleaning. SP11 is often desirable to avoid damage to the surrounding lining that may be in very good condition. Use of power to meet 11 requirements must include the use of abrasive disc, flopper wheels, needles, or steel point that provide the specified angle profile. So inaccessible area where blasting cannot be done, we can go using a power tool. So SP5 white metal blast cleaning, SP10 near white metal, SP11 power tool cleaning. To facilitate inspection and ensure good adhesion, surface preparation by abrasive blasting and the power tool extend several inches beyond area to be lined. So we have to abrasive blast not on the exact lining area, it is several inches away from this. So how many inches minimum we are going for lining? 2 inches away from the weld. So okay, we have to go more than that. Then pre-cleaning. Prior to abrasive blasting, all hydrocarbon residues such as oil, tar, and grease must be removed from the area to be lined. Solvent cleaning and high or ultra high pressure water or steam cleaning using the proper chemicals are effective methods in accomplishing complete hydrocarbon removal. Cleaning is typically followed by a clean fresh water rinse to ensure complete. So you have to first clean it before this blasting. Then bottom repair and subsequent weld. The repair of perforation of the steel tank bottom shall be performed by welding of a steel patch plates or replacement bottom plate. Epoxies and other non-steel shall not be used for repair. Perforation means holes. Suppose bottom there is small holes. You have to, before applying lining, you have to use a patch plate or replacement plate. But you cannot apply a paint, epoxy. Yeah, epoxy to cover the hole. Then NACE SP 178 can be used to specify the surface finish of the welds and the steel components. Typically, weld finish as per SP 17C and D is specified where feasible. That is open book question. Then what should be the surface profile? Roughness. This is open book question, page number 22. The lining manufacturer recommendation for surface profile depth must be achieved to optimize the mechanical adhesion. The anchor pattern required for lining is typically 1.5 to 4 mils, 38 micrometer to 102, and generally increase with the thickness of the lining. To achieve adhesion necessary for long-term performance, it is important that the anchor pattern is sharp and angular. That is open to question. 1.5 to 4 mils roughness. Then lining application. Highlight this one. When you're holding a primer is used, it is important that it is applied according to the manufacturer instruction for film thickness, as excessive thickness may have adverse effect on the intercoat. So primer should be manufacturer instruction only you have to follow. Then this one. If coatings exceed the suggested recoat windows, then the coating might be properly prepared in accordance with the manufacturer recommendation. We have to follow always the manufacturer recommendation. Then highlight the last lining. After adequate curing of the complete lining, holiday testing should be performed. Any defect should be repaired in accordance with the coating material manufacturer recommendation and the written specification. So you have to follow manufacturer recommendation and the written specification. Open book question. Suppose there is a difference between owner operator recommendation and owner specification. Manufacturer recommendation is saying different. Owner specification saying it should be resolved. Any difference between the owner operator specification and the lining manufacturer should be resolved before beginning the job. So before beginning, it should be resolved. Open the question. what should be the surface temperature? The temperature of the steel surface should conform to the lining manufacturer recommended application and curing ranges. As a rule, the surface temperature at least 5 degrees Fahrenheit above the dew point temperature of the tank. That is very important closed book question. And the humidity should be less than 80 degrees Fahrenheit at the steel surface. Humidity less than 80%, temperature above 5 degrees Fahrenheit above dew point. Then curing 8.5, highlight the first line. Improper application and inadequate curing are the major cause of premature lining failure. So only inadequate application and not cured. That is a major reason failure. Then inspection 9.1. Second line, the lining installation should be inspected throughout all phases of work and upon completion of the work. The performance life of a lining is directly related to the surface preparation, application, and curing. Next line is open book question. Documents should include daily inspection record. We should inspect daily. Daily progress, we have to inspect it. Daily inspection report, you have to prepare to capture the project activity, issues, and complaints for the written procedure and the specification. That is a open book question. Then what is the qualification is required for the inspectors? Either they should be NACE or SSPC qualified. All lining inspectors should be either NACE or SSP certified and should have demonstrated thorough knowledge of coating and lining practice. That is closed book question. Then lining discontinuities. Now, when you are checking thin film lining with the holiday test, we have to use a 67.5 volts. That is specified. What is the thin film lining? What is the voltage is 67.5. For thick film lining, you should use a high voltage. But the problem is when you are using very high voltage, see what will happen. Generally, linings are not conductive, except the inorganic zinc that is conductive. That's why holiday test we cannot do. When you are using very high voltage, the lining become conductive. It will pass current. That what is the voltage limit is called a dielectric strength. Dielectric strength at which voltage the non-conductive material become conductive. Okay. Holiday testing of thick film shall be performed with a high voltage detector in accordance with the NACE SP 188. That is closed book question. Holiday testing thin film should be performed with a low voltage 67.0 volts bed sponge detector. When testing with the high voltage, it is important the voltage be properly set in accordance with the manufacturer recommended volts per mil and the film thickness properly matches specified. Otherwise, damage may occur from the testing operation. Then repair. A properly selected and applied tank bottom lining should be expected to provide a minimum service life of 20 years. Some lining, most notably thick film, may provide 25 to 30 years. So thin film 20 years, thick film 25 to 30 years line. Then evaluation. How we will check lining is good condition. Lining evaluation include the visual inspection, adhesion.
Sir, hello, sir. Sir, Nagaraj.
Okay. There is a power disturbance. I will restore it. No problem.
கேக்குதா சார்?
கேக்குது கேக்குது கேக்குது. உங்களுக்கு கேக்குதா?
10.2 சொல்லும்போது அப்ப எனக்கு ஃப்ரோஸ் ஆயிடுச்சு சார்.
என்ன சொன்னப்ப?
10 பாயிண்ட் நீங்க ஆரம்பிக்கும்போது எனக்கு ஃப்ரீஸ் ஆயிடுச்சு சார்.
Okay, just we will repeat it. Okay, because there is a. Okay, right. We will repeat that 10 because there is a small disturbance here. Okay, now it's okay. So 10.1. A properly selected and applied tank bottom lining should be expected to provide a minimum service of 20 years. So generally thin film lining 20 years, whereas thick film and private 25 to 30. That is a closed book question. Then how to evaluate the lining? Lining evaluation include visual inspection, adhesion measurement, audible testing, and a physical examination of the lining sample. Now, this is what it says. Suppose lining absorb moisture. Moisture means water. Water is a conductive material. Suppose the lining have moisture, when you do Hall-Day test, it may damage the lining because it will conduct. Generally, Hall-Day test we are doing only on a non-conductive materials. Conductive materials. So what is the holidays? Breaks in the non-conductive linings or the painting coating. When conductive materials only, it will conduct this one. So you can see here, Hall-Day testing is not typically recommended for lining that have been in previous service, since the presence of moisture in the can cause damage when exposed to voltage. In some instances, this has been successfully achieved after the tank has remained open. So suppose you have doubt, you have to dry the lining to remove the moisture, then you have to go for Hall-Day test. Okay. So consultation with the coating manufacturer attempting this type inspection is necessary. That is open book question. Then please go to the what is mean by repair, what is mean by replacement. Repair means if in any area there is a holiday, you are making repair coating, repair. Even top coat is considered as a repair. Suppose thickness is reduced, we want to apply one more coat. It is repair. Replacement means completely remove the lining, then again applying it. The repair of a lining typically used with either portion of the lining will be replaced or when all of a portion of the lining will be top coated. The replacement is used when all the exit completely removed and the steel substrate and the new lining is applied. Then repair and top coating specification 10.6.2.4. Consideration should be given to the lining manufacturer recommendation when developing the repair specification. All difference between this RP and the specification, procedure, inspection and test plan, and the manufacturer recommendation should be resolved before starting any lining repairs. Suppose any contradiction between the specification, manufacturer recommendation, 652, we have to first resolve it. Which way we are going to do this before starting? Then please go to the page number 29, tank entry 12.2. Guidelines for issuing permits and preparing a tank or confined space under detail AP 2015, including evaluation of atmospheric hazards and tag out process. That's all 652. So let us go to the question.
Lunch போய்ட்டு 1:30 வந்துடலாமா சார்?
No lunch today. After lunch there is no class.
Yes.
So we just another 30 minutes. Huh?
Okay.
Manage. We will continue and finish it. Afternoon there is no class.
Okay, sir.
You want to practice? Okay, so no problem. So people want to practice on their own. Okay, so அந்த இது ஸ்டார்ட் இது பண்ணிங்கம்மா, ரெக்கார்டிங் ஸ்டாப் பண்ணிங்க.
ஸ்டாப் பண்ணிக்குவா சார் ரெக்கார்டிங்?
ஆமா ஆமா எடுத்துருங்க, ஸ்டாப் எடுத்துருங்க.
ஓகே.